Good morning, everyone. In the last class, we have discussed something about the basic fundamental points of lasers regarding the population inversion and how many types the matter attracts energy and so on so forth. Now, in the present lecture, we are going to discuss one type of laser. Before going into the topic, let us know how many types of lasers we have. We have different types of lasers, namely solid state laser. Example is a ruby laser and a ND-YAG laser. We have a gas laser. Example is a carbon dioxide laser is one example. Helium neon laser is another example. And we have a semiconductor laser, homojunction semiconductor laser, and a heterojunction semiconductor laser. So before going into the different types of laser, let us start with the solid state laser and a ruby laser. Coming to the topic of a ruby laser is a three-level solid state laser which was invented by T. Maiman in 1960. It was the first laser and is made up of a solid state material, and the solid state material used for the construction of a ruby laser is aluminum oxide, Al2O3 and Cr2O3, a combination of Al2O3 and Cr2O3. Now this Al2O3 and Cr2O3, by addition of the chromium atoms with a percentage of 0.05%, the ruby rod will turns pink in color. And the basic construction of a ruby laser, in fact the basic construction of any laser should contain the three main chief components, which are nothing but the active medium and pumping mechanism and resonator cavity. So these three are the main important concepts we need to look for. So the active medium, where is the active medium? Here is the active medium is the ruby rod. Here is the ruby rod which acts as the active medium. The atoms of the ruby rod acts as the active medium, where the chromium atoms will be the main active medium there. Now the pumping mechanism is done by using the helical xenon flash lamp, which is used to pump the atoms of the chromium atoms to the from the ground state to excited state. And the helical xenon flash lamp will emit a pulse of light, a strong pulse of light with the wavelength of 5600 angstroms. 5600 angstroms. Now the third main important component of laser is a resonator cavity. So for that purpose, what we need to do is, the ruby rod is highly polished such that one is partially reflecting and the another end of the ruby rod is fully reflecting. The partially and where from which end the light has to be emitted, that end has to be partially reflecting. Maybe the right end of the ruby rod is partially reflecting and the left end of the ruby rod is fully reflecting. And usually if you look at the length of the ruby rod, it will be around 4 to 5 centimeters, and the diameter of the ruby rod will be around 5 to 10 millimeter. Now if you look at this is the construction diagram of a ruby rod. So in the construction diagram, we come across all the three main components of laser. One is active medium, which is a ruby rod. Next, pumping mechanism, a helical xenon flash lamp, and the resonator cavity. The partially reflecting surface and the fully reflecting surface of the ruby rod constitute resonator cavity. Fine. Now let us discuss the working of a ruby laser by using the energy level band diagram. Now this is the energy level band diagram. Here we have a ground state. A ground state is there. Here we have a ground state and an excited state, and we have a metastable state. One metastable state is there. So usually, if you look for any laser system, there will be another state called metastable state. Apart from ground state and excited state, we have a metastable state with a higher lifetime. Therefore, in a ruby rod, there is a metastable state with a longer lifetime of order 3 into 10 power minus 3 seconds. So if you look at the band diagram, this is the energy band diagram of a ruby laser, which is a ground state and excited state and metastable states. Usually, at room temperature, the atoms will be in the ground state. Most of the atoms will be in the ground state. Now, what will happen? We are supplying an energy from external source by using an optical xenon flash lamp. An optical pulse of wavelength 5600 angstroms is allowed to instant on the material ruby rod. Thereby, the atoms of the ruby rod in the ground state, which will gain energy and are excited to the excited state. We have two more excited states here. After that one, the atoms are staying in the excited state for a lifetime of 10 power minus 8 seconds. So the lifetime of atoms in the excited state is 10 power minus 8 seconds. After the completion of the lifetime, the atoms will come down or make transition to metastable states. Some of the atoms will make transition to metastable state, and some of the atoms will come down by making transition to ground state. Now the transition between excited state and a metastable state is purely non-radiative transition. That means the emission will take place, energy release will take place in the form of a heat. Now, after some time, if you look at the laser system, the atoms are in the metastable states. Most of the atoms will present in the metastable states. Number of atoms in the metastable states will dominate the number of atoms in the ground state. That is, N2 is greater than N1. That is, a situation is arrived such that a population inversion is achieved. After achieving the population inversion, because of the stimulated emission, what will happen? The atoms in the metastable state make a downward transition to the ground state by emitting a pulse of light of wavelength 6943 angstroms. So what is the wavelength of the pulse of light emitted by the Ruby laser? It is 6943 angstroms, but it is not a laser output. To be fact, that is not a laser output. A pulse of light is reflected back from the partially reflecting surface because of the resonator cavity in the construction we have seen there. A pulse of light will be reflected back from the partially reflecting surface. It will move back and once again reflected back at this mirror, fully reflecting surface, and once again it will move forward and it will excite an atom in the metastable state. Because of that, an atom will make a downward transition to the ground state, releasing another photon of wavelength 6943 angstroms. Therefore, it is clear that a single photon, we are getting single photon becomes two photons, two photon becomes 4, and 4 becomes 8, and 8 becomes 16. And the number of photons get multiplied and the light get amplified. After getting sufficient energy, the pulse of light will be emitted. A bunch of photons will be emitted like a beam of very powerful intensified radiation called a laser beam of wavelength 6943 angstroms. So this is the basis understanding of the Ruby laser regarding the construction diagram and the band diagram. So if you look at the band diagram, it is clear that we have one metastable state. In fact, we can show two metastable states because Ruby laser is said to be a 3-level solid state laser, and helium neon laser is said to be a 4-level solid state laser. It is a 3-level solid state laser, means we come across two metastable states. One metastable state, the emission between the metastable state and the ground state, one metastable state and another on the ground state will give us a wavelength of 6943 angstroms, and the another transition between another metastable state to ground state will give us a wavelength of 6929 angstroms, and this wavelength is completely filtered, and only we are allowing this wavelength 6943 angstroms to come out as a laser beam. And if you look at we have several applications of the advantages of the Ruby laser, and Ruby laser have certain disadvantages. Because of these disadvantages factor, we have to switch on to the another laser called helium neon laser. It's a gas laser, a 4-level gas laser invented by Ali Jawan in 1961. So it is clear that in the energy level diagram, there is a one spontaneous emission, and stimulated emission is followed by the spontaneous emission, and the radiation and the transition between excited state and metastable state is a non-radiative transition, and therefore we need to supply a cooling system inside the material so that to avoid the damage of the Ruby rod. Thank you very much. Thank you.